Also, materials supplied into the market are also going to be independently characterized by Intertek. Intertek MSG is the arm of the Intertek measurement group itself, who've been doing this in traditional markets for the best part of the last 120 years. So it's nothing new to them, right? The other side of the coin is the exchange process delivers transparent pricing. You can see what you're paying for. For example, if I want to buy a barrel of oil, I can log onto a screen or ring a broker and he's going to give me a price of what crude is today, or what it's going to be in 3 months' time, or what it's going to be in 2 years' time. Can I do that within an engineered nanomaterial? I can't. And the reason why transparent pricing is important is because it enables the demand side, the person who's actually buying the material, who's going to use it to make it into something, they can price in the production costs. I mean, for example, if you're going to make an end product, you need to know what your input costs are in advance, because that's how you're going to price what you're going to expect this gentleman here done to buy from you, right? You can't do that at this present moment in time. There's no assurances. Points of departure for global insurers. This is very important because we're actually working with one of the largest insurance syndicates in the world based in the UK to discuss how we actually deal with the issue of insuring nanomaterials. It's a very wide issue, and a lot of insurance syndicates are very concerned about this. For example, I'm not going to draw a direct comparison between nanomaterials and some of the scares that have happened before, but for example, asbestos, right, and I'm not comparing nanomaterials to asbestos, asbestos nearly collapsed the global insurance market. Nearly collapsed it. I mean, provisions that had to be made to stop the collapse of indemnification, which is something that's been enshrined in law in this country since the 16th century, was nearly caused by asbestos. And the insurance market, make no doubt about it, they are not going to put themselves out on a limb to insure materials that do not have those standards in place. And that is a simple fact. They're not going to do it. Okay, they've been burnt before, and they're certainly not going to leave it open again. That's not to say that nanomaterials are going to cause a problem. For example, like carbon black, since the 1930s, been used in auto tires and so forth, and this hasn't caused a problem yet. But they're not going to enter into the world of unknowns. Insurance isn't about that. Insurance is about risk mitigation. It's about balancing reward, the reward you will get against the value of something. Now, the exchange itself has also established lines of contact with ISO Committee 229. Now, most people familiar with nanomaterials will know that the ISO Committee 229 is peculiar to engineered nanomaterials, and they're actually trying to set a number of standards and so forth within the field. And in conversations with representatives of ISO, they've actually come to us and said, look, we've got a major problem. And the major problem they have is that ordinarily industry sets a standard and then presents that standard to the ISO as a template. They haven't had a template from industry. They haven't had a template from nanoscience and nanotechnology. So basically what they're trying to do is they're trying to preempt in advance what industry will first of all make. I mean, when I talk about industry, I'm talking about nano industry. And secondly, what people will buy, what the consumer will buy. It's an impossible task. Very, very difficult to do, and it's taken decades to do that in traditional materials, never mind nanomaterials. And as we know, nanomaterials have got an infinite number of combinations that you can have and functionalized variants, and etc., etc. So for example, trade integrity and traceability. Trade integrity is the financial and material performance of the trade. It means that you get paid and you get the material that you actually order. And those are very, very important, and that is actually what's missing from our industry. And that's what makes it so difficult for a lot of things to happen. I mean, for example, capital. How can capital reallocate to businesses involved in nanoscience and nanotechnology when you cannot quantify the raw materials base? I mean, can you imagine the world's oil market? Can you imagine the oil market without a commodity exchange? Can you imagine the price of a loaf of bread without a wheat exchange? Think about it. I mean, for example, we're complaining at the moment because the price of a loaf of bread has gone from, I don't know, 60, 70 pence up to £1.80. But I mean, that's to do with the fact that there's an excess demand coming through from the bio side. I mean, that's a phenomenon that will probably correct itself in due course. But can you imagine if you didn't have a commodity exchange in the first place, anybody would be able to make up the price of a loaf of bread. You walk into one shop, it could be £4. You walk into another, it could be £5. Somebody could even pull the Chancellor arm and charge £10 for it. You know, I mean, business cannot operate without basic standards. And nanotechnology has got one key feature associated, and that is acceleration. It has the ability, if it develops traction to accelerate, to basically supplant existing, complement existing industries, and ultimately converge. And that is something that we need the exchange process to do, to develop a cross-sectional phase-out and phase-in strategy. And when I'm talking about a phase-out and phase-in strategy, I'm talking about how markets deal with innovation. Innovation is nothing new in markets. Okay, for example, we went from the wheel, we went to the locomotive, we went to the diesel engine, we've gone to the jet turbine. And in each stage, markets have adjusted to compensate for downturns in one sector and switching of capital that's been tied up in the resource, i.e. labour, plant, into new manufacturing systems, so it enables the world economy to adjust. At its most simplest, IBM started making calculators, crank machine calculators. Today, they're probably one of the most sophisticated IT companies on the planet. They didn't stay still. They adjusted and modeled their business accordingly. And past examples out of that, I mean, we have to think of capital as a bit of a juggernaut. It's like if you can imagine trying to turn a truck on a highway that's doing 60 miles an hour. It takes a long time. You just can't slam on the brakes and all of a sudden change direction. You've got to plan in advance. You've got to gear down the machine to be able to stop, and then you can turn and so forth. Capital works very, very similar. It takes a long time, and I think Tim alluded to it earlier about how technologies take a long time to embed into the commercial world, 10 to 20 to 30 years in some places, as he alluded to. That's quite correct. And the reason being is not that the potential isn't there, it's the fact that capital has to readjust to it. Right. So for example, the exchange mechanism, what's it going to do at its basis? It's going to be a mechanism to coordinate the allocation of material resources. In our case, we've got to think of those material resources as being nanomaterials, but we have to stop deluding ourselves. They are raw materials. They're no different from being a raw material as a barrel of crude oil is a raw material that I can get petrol from. Okay, a nanomaterial is obviously a different material, but in an industrial context, it's nonetheless a raw material. It's something that's going to be used to be processed into either an end application or an end product. So basically, if we look at the world and understand why the investment community is sort of looking at nanotechnology and scratching its head, and it is. I mean, we've had regular conversations with leading investment institutions, and to be perfectly honest with you, they've been keeping a watching brief on nanotechnology for a considerable period of time. I think there was a comment earlier on as to why an IPO was pulled in the United States in 2004. Well, there was very good reasons why it was pulled. And it wasn't because the investment banks themselves got shy, or the fact that the Iraqi war was started in 2004 and the Dow Jones was sitting at 7,000. There were other reasons why that IPO was pulled. And basically, within our industry, this exchange will provide a basis for the investment community to be able to quantify what is the real trade, financial volume going through the base materials that underpin nanoscience and nanotechnology. That's how you value an industry. You don't turn around and try and value an oil industry by saying, oil is a wonderful thing, I can make petrol out of it. The first question you ask yourself is, how much does a barrel of oil cost? How much does it cost to put that barrel of oil through that refining capacity to get my gallon of petrol? That's how you price a business model. And that's a function that commodity exchanges perform. Now, if we establish, or we are going to establish the commodity exchange anyway, if we establish the exchange, attracting the direct interest and involvement of the investment community, that's twofold. In the first instance, they're going to see a new industry that's actually developed some form of tangible proof that it's got a value. Potential is not a value. Potential is a wonderful thing, but potential that cannot be quantified, or that is elevated to a situation where it's either too wonderful to be believed or too pessimistic to be invested in the first place, you need to be able to quantify what that potential is. And you start quantifying by starting quantifying the raw materials place of nanoscience and nanotechnology.